Students, here we have to prove the integral of 1 upon a square sin square x plus b square cos square x whole square between the limit 0 to pi by 2 is pi times a square plus b square divided by 4a cube b cube. So, for proving this integral, first we take the integral 1 upon a square sin square x plus b square cos square x between the limit 0 to pi by 2. Now, first we integrate this. So, for integration this, first we divide the numerator and denominator by cos square x. So this can be written as 1 upon cos square x divided by a square sin square x divided by cos square x plus b square cos square x divided by cos square x. So for integration this, first we divide numerator and denominator by cos square x. So this 1 upon cos square x can be written as sec square x, and this sin square x upon cos square x can be written as tan square x, and this cos square x cancelled by this cos square x, so this is b square. Now in the denominator, this a square tan square x can be written as a tan x whole square plus b square. So for this integration we use here substitution. So put here t is equal to a tan x. Now we differentiate this t with respect to x, so we get dt upon dx. A is the constant here and differentiation of tan x is sec square x. So from here we can write dt upon a is equal to sec square x dx. So in the above integral I, we put value of sec square dx, that is dt upon a. So dt upon a here, and in place of a tan x we put here t, so this becomes t square plus b square. We can see here in place of a tan x we put here t, so this is t square plus b square. In place of sec square dx we put here dt by a. Now we change the limit, because we know that when lower limit x equal to 0 here, we can see that the lower limit in the above integral is 0, so this becomes t is equal to a tan 0, and we know that tan 0 this is equal to 0, so t is equal to 0. When x is pi by 2, so t is equal to a tan pi by 2, and we know that tan 90 is infinity, infinity multiplied by a, this is infinity. So the limit of this integral becomes 0 to infinity. We can see that this a is constant with respect to t, so it outside the integral sign, 1 upon a 0 to infinity 1 upon t square plus b square dt. Now we integrate 1 upon t square plus b square. We know that integration of 1 upon a square plus x square is 1 upon a tan inverse x by a. So the integral of 1 upon t square plus b square 1 upon b tan inverse t upon b. Now here we write upper limit minus lower limit. So in place of t we write here infinity. So this is tan inverse infinity by b, that is infinity, minus in place of t we put here 0. The 0 by b is 0 here. And we know that tan inverse infinity is pi by 2 and tan inverse 0 is 0. So this becomes pi upon 2ab. Here we put, in place of t we put here upper limit, that is infinity, so infinity divided by b gives infinity, and tan inverse infinity is pi by 2. Similarly, lower limit 0, in place of t we put, so this is 0 by b, that is 0, so tan inverse 0 is 0 here, so integral of this is pi upon 2ab. So we can see here integral of 0 to pi by 2 of 1 upon a square sin square x plus b square cos square x dx is pi upon 2ab. We suppose that this is equation second. Here we can see that this is the equation second. Now we have to prove the integral of 1 upon a square sin square x plus b square cos square x whole square. So first we differentiate second with respect to the parameter a. So when we differentiate with respect to the parameter a, this becomes d by dA of integral 1 upon a square sin square x plus b square cos square x is equal to, here pi upon 2b, this is constant here, and d by dA of 1 upon a. Here we differentiate the equation second by the parameter a. So if this d by dA goes inside the integral sign, this converts partial, so this can be written as integral of 0 to pi by 2 del by del a of 1 upon a square sin square x plus b square cos square x dx is equal to pi by 2b is constant here, and differentiation of 1 upon a with respect to a, this is minus 1 upon a square. In the right hand side we can see here the differentiation of 1 upon a with respect to a is minus 1 upon a square, so right hand side becomes minus pi upon 2b a square. And in the left hand side, this ordinary differential operator d by dA goes inside the integral sign, it converts in partially. Now when we differentiate this 1 upon a square sin square x plus b square cos square x partially with respect to a, we suppose that this is a square sin square x plus b square cos square x, this is equal to a, so differentiation of 1 upon a is minus 1 upon a square. So this can be written as minus 1 upon a square sin square x plus b square cos square x whole square. And when we differentiate a square sin square x plus b square cos square x, so sin square x is constant here because we differentiate partially with respect to a, and differentiation of a square with respect to a is 2a, and differentiation of b square cos square x is 0 because we differentiate partially here with respect to a. And in the right hand side this is minus pi upon 2a square b. So we can see here in the left hand side, inside the integral there is minus 2a which is constant with respect to x, so this is outside the integral sign, so here we can write minus 2a pi by 2 sin square x dx divided by a square sin square x plus b square cos square x whole square, this is equal to minus pi upon 2a square b. Now we can see here this minus 2 in the left hand side goes in the right hand side in the denominator, so right hand side becomes 0 to pi by 2 sin square x dx divided by a square sin square x plus b square cos square x, this is equal to, this minus cancelled by this minus, and this pi upon this 2 multiplied by 2 gives 4, and a multiplied by a square, this is a cube, and b here. Suppose that this is equation number 3. So here we can see that the integral of the integral of sin square x dx upon a square sin square x plus b square cos square x whole square between the limit 0 to pi by 2 is pi upon 4a cube b. Now we differentiate the equation second with respect to b. Now differentiate equation second with respect to b. So we can write here d by db of integration of 0 to pi by 2 1 upon a square sin square x plus b square cos square x dx. This is equal to, here we differentiate with respect to b, so pi upon 2 is constant, and differentiate 1 upon b with respect to b. Now we differentiate this. So in the right hand side we can see that differentiation of 1 upon b with respect to b, this is minus 1 upon b square, and this d by db goes inside the integral sign, so this becomes del by del b of 1 upon a square sin square x plus b square cos square x dx. We know that if the ordinary differentiation goes inside the integral sign, it converts into partial. And in the right hand side, the differentiation of 1 upon b with respect to b is minus 1 upon b square. Here pi upon 2 is constant because we have to differentiate here with respect to a. Now we differentiate in the left hand side with respect to b partially. So we suppose that 1 upon a square sin square x plus b square cos square x, this is equal to b. So differentiation of 1 upon b with respect to b is minus times 1 upon b square. So this can be written as 1 upon a square sin square x plus b square cos square x whole square. Now we differentiate this a square sin square x plus b square cos square x. So we can see here a square sin square x is constant. So differentiation of a square sin square x 0 because we differentiate partially here with respect to b. Now we differentiate b square cos square x. So cos square x is constant because we differentiate here with respect to b partially. And differentiation of b square is 2b here. And in the right hand side this is minus pi upon 2ab square. So in the left hand side we can see here this minus 2b is constant, so it will be outside the integral sign. So minus 2b integral of 0 to pi by 2 of cos square x dx divided by a square sin square x plus b square cos square x whole square, this is equal to minus pi upon 2ab square. In both the sides we can see that this minus is cancelled by this minus, and this 2b goes right hand side in the denominator. So this can be written as integration of cos square x dx divided by a square sin square x plus b square cos square x is equal to pi upon 4ab cube. Here we can see that this 2b goes in the right hand side in the denominator, so 2 multiplied by 2 gives 4 here, and b multiplied by b square gives b cube here. Suppose that this is equation number 4. Now we adding equation 3rd and 4th. Now we adding equation 3rd and 4th. So we write here integration of 0 to pi by 2 of sin square dx divided by a square sin square x plus b square cos square x whole square plus integration of cos square x dx divided by a square sin square x plus b square cos square x whole square between the limit 0 to pi by 2. This is equal to here pi upon 4 a cube b plus pi upon 4 a b cube. Here we add the integrals third and fourth, we get this one. Now in the right hand side we can see that if we taking here LCM, that is 4 a cube b cube, so here 4 b pi b square plus here pi a square. Now in the numerator we taking common here pi, so this becomes pi times a square plus b square upon 4 a cube b cube. We can see that in the right hand side when we taking LCM 4 a cube b cube, so this 4 a cube cancelled by this 4 a cube and b cube divided by b, we get b square multiplied by pi, we get pi b square. Similarly here we get pi a square. Now we taking common pi from these both terms. Now in the left hand side we can see here both the integrals have the same limit 0 to pi by 2, and in the both the integrals this denominator is same. So the numerator will be add. So we can write here in the left hand side, we can write here 0 to pi by 2 integration of sin square x plus cos square x multiplied by dx divided by a square sin square x plus b square cos square x whole square. Now we can see here this sin square x plus cos square x is equal to 1. In the numerator here sin square x plus cos square x is equal to 1. So we write here 0 to pi by 2 dx divided by a square sin square x plus b square cos square x whole square. This is equal to pi times a square plus b square upon 4a cube b cube. So the integral is pi times a square plus b square upon 4a cube b cube. Thank you.